Dear students, next we are discussing the topic function. So, what is a function? So, actually, a function is a relation. Function is a relation from A to a set to B. So, what's the property? If every element of A, set A, has one and only one image in set B, so called function. What is that? Every element of a set A has one and only one image in set B. It is denoted by f. F from A to B. F from A to B. So this is called a function. So look at here. If f is a function from A to B and AB belongs to F, ordered pair AB belongs to F, then we can say that f of A is equal to B. So that means image of A is B, or we can say that B is called the image of A under the function f. And also we can say that A is the pre-image of B. So here B is the image of A and also A is the pre-image of B under the function f. So actually f is also a relation. We can go through some examples. So first of all, look at here. I am letting a relation R. It's a relation x comma y is equal such that y is equal to x and xy belongs to n. N means set of all natural numbers. So I am going to check whether it is a function or not. So what is a function? Every element of A has one and only one image in B. That's the condition of a function. So as a relation, we can get the domain of R. What is the domain? Domain means set of all first elements. So here x. What is x? X belongs to n. Set of all first elements is called domain. So here the first coordinates belongs to n. So we will get domain is equal to n, set of all natural numbers. So we can write every natural numbers here because x belongs to n. So domain of R is equal to n. What is codomain? Actually, this relation is defined on n. That means this relation, or we can say that this function is from n to n. Defined n. That means this is n to n. So here this set is called codomain. So here we can say that codomain of R is equal to n. But what is range? Range is the set of all second elements. Set of all second coordinate is called the range. So what is y? Y is equal to 2x. Y is equal to 2x. 2 into x. What is x? X is natural number. So here, if we are looking y, we get 2 into 1, 2. 2 into 2, 4. 2 into 3, 6. 2 into 4, 8. 2 into 5, 10. 2 into 6, 12. So what is y? Y is equal to 2 into x, 2x. X belongs to n. X is equal to 1, 2, 3, 4, 5, 6, etc. And y is equal to 2 into x. So we will get only the set of our even natural numbers 2, 4, 6, 8, 10, 12, etc. So range of R is the set of our even natural numbers. Next we are going to check whether R is a function or not. So what is the definition of function? Every element of n has one and only one image in n. So here the function or the relation is from n to n. So what is the condition of a function? Every element in n has one and only one image in n. This is A, this is B. So this is natural numbers A, this is again natural numbers B. So if we are letting an element n belongs to n, we will get the image to n. So every natural number n has one and only one image to n. So we can say that R is a function, because in every x we can find 2x. In every x we can find 2x. That's why this R is a function. For another example, look at here. R from n to n defined by R is equal to x comma y is equal to x minus 1. Is it a function or not? We are going to check that. Y is equal to x minus 1. If I am letting x equal to, this is x comma y belongs to n. N means set of all natural numbers, that is 1, 2, 3, 4, etc. It's called set of all natural numbers. So if I am letting x equal to 1, what we will get? Y. Y is equal to x minus 1. So x equal to 1. So 1 minus 1 is equal to 0. But in set of all natural numbers, there is no 0. So y does not belongs to n. Here x and y belongs to n. But 0 does not belongs to n. So for x equal to 1, there is no image. In natural numbers. So we can say that this relation is not a function. Not a function. Because for x equal to 1, we cannot find an image for x equal to 1 in n. We cannot find an image. So that's why this relation is not a function. But here, for every n, we can find 2n. Also, this 2n belongs to natural numbers. That's why this relation is a function. And also look at some examples here. First one, R is equal to 312157. Is it a function or not? Is it a function or not? Here we have the domain is 3, 2, 5 and the codomain 1, 7. 3 to 1, 2 to 1 and 5 to 7. This is a function because here the 3 has one image 1 and 2 has one image 1 and 5 has image 7. So this is a function. This is a function. This is the domain. This is the domain of that function. This is the domain. And this is the range and codomain. Range and codomains are same. Here range and codomain are same. So look at the next one. Look at the next one. Look at the second one. What is that second one? 2, 1, 2, 3, 4, 4, 5, 4. So here domain is the first elements 2, 4, 5. And the codomain is 1, 3, 4. 1, 3, 4. Then look at the mapping. 2 maps to 1. 2 to 1. 2 to 1. Again 2 to 3. This is not happened. In a function, an element should be one and only one image. But here the element 2 has two images. The element 2 has two images. The element 2 has two images. So that's why this is not a function. This is not a function because the element 2 has two images. This is a relation, but this is not a function. And also the remaining mappings are 4 to 4, 5 to 4. These are not problems, but here problem is the element 2. 2 has 2 images. So that's why this is not a function. Actually, this is a relation. We can count this as a relation, but this is not a function. Look at the third one. This is the second one. Look at the third one. 1, 2, 2, 3, 3, 4, 4, 5. So domain, what is the domain? 1, 2, 3, 4. What is the codomain and the range? 2, 3, 4, 5. 1 to 2, 2 to 3, 3 to 4, 4 to 5. No problem, because every element in the domain has image in the codomain. 1 has image, 2 has, 3 has, 4 has, every element has image in this codomain. And also, for every element there we have only one and only one image. So this is a function. This is a function. So look at here. What is a real valued function? Real valued function. That means its range should be the real numbers or the subsets of real numbers. Its range should be real numbers, set of real numbers, or one of its subsets. So here, look at here. What is the range? Here, range is equal to 1, 7. Here, the range is equal to 1, 7. So here we can in the first one, range is equal to set to 1, 7. Actually, 1, 7 is a subset of set of all real numbers. Second one is not a function. What is the third one? In the third one, range is equal to 2, 3, 4, 5. The set of all second coordinates. 2, 3, 4, 5 is also a subset of real numbers. So that means these two functions are real valued function. And also, what about this one? The first one. Actually, here the range is equal to set of all even natural numbers. Set of all even natural numbers is also subset of R. So that's why this is also a real valued function. So look at the next example. F from n to n, that means natural numbers to natural numbers, defined by f of x equal to 2x plus 1. F of x equal to 2x plus 1, comma x belongs to n, comma x belongs to n. 2x plus 1. This is the function. So we are going to find the image of every values of n. So natural number is starting from 1. So what is the value of f of 1? F of x equal to 2x plus 1. Then f of 1 is equal to 2 into 1 plus 1. F of x equal to 2 into x plus 1. Then f of 1 is equal to 2 into 1 plus 1. That means 3. What is f? What is the image of 2? F of 2. That is 2 into 2 plus 1. 2 into 2 is equal to 4. 4 plus 1, 5. What is the image of 3? F of 3. That means 2 into 3 plus 1. So 6 plus 1, 7. What is the image of 4? That is f of 4. That means 2 into 4 plus 1 is equal to 9. So this is not finite. We can find every natural numbers here. 4, 5, 6, 7, 8, 9, 10, etc. Then we will get the image of that natural number. So for example, what is the image of 171? What's the image of 171? That means f of 171. F of 171 is equal to 2 into 171 plus 1. 2 into 171 plus 1. What is the value for that? So we'll get 3, 4, 3. Am I right? 2 into 171 is equal to 342 plus 1, 343. So for every natural number x, we can find the image to x plus 1. So in the chronological order, we can find the image. Image of 1 is equal to 3. x comma y. Here we are writing the coordinates like this, x comma y. So here x and f of x is equal to y. Y is the f of x. So x, if x equal to 1, image of 1 is equal to 3, image of 2, 5, image of 3, 7, image of 4, 9, image of 5, 11, image of 6 is equal to 13, image of 7 is equal to 15. And also here, image of 171 is equal to 343 and etc. This is not finite, this is infinite set. So we can find infinite numbers here and also infinite images. And look at here, there is no repeated images. Here for 1, we have only one image. For 2, we have only one image. So we can say that this is a function. Without any doubt, we can say that it's a function. So look at the next example, f from R to R such that f of x equal to x square. F of x equal to x square. So here R is the set of all real numbers. Actually, this is set of all natural numbers. So we can find the first element, second element, third element. We can find like this. But in set of all real numbers, we cannot find the starting number or the what was the next number. We cannot count the elements from real numbers. So in this case, we are choosing some arbitrary numbers like -3 and -2, -1, 0, 1, 2, 3 like this. Actually, in between 0 and 1, we can find 0.5. And we can also find here 3.1. So this is set of all real numbers. We cannot find the first number, second, we cannot find like that. So what is the image of -3? That is -3. F of x equal to x square. Then f of -3 equal to -3 square is equal to 9. F of -2, that is -2 square is equal to 4. -1 square is equal to 1. 0 square 0. What is 0.5 square? 0.5 square is equal to 0.25. 1 square is equal to 1, 2 square 4, 3 square 9. What is 3.1 square? I think this is 9.91. You just verify these numbers, okay, these images. So look at here, next we are dealing from graphs, how we can write the graph of some functions. So next I am dealing with identity function. What is identity function? F of x equal to x, identity function. The image of x, the number itself, or the image of x, the x itself, is called identity function. F of x equal to x. Here it is from f from R to R. So we have told about these real numbers. We cannot find a starting number, but in this case we are letting -3. So what is my f of -3? Image of -3. F of x equal to x. Then f of -3 is equal to -3. There is no doubt. F of x equal to x. Then f of -2 is equal to -2. Then f of -1 is equal to -1. F of 0, 0. F of 1 is equal to 1. F of 2, 2. F of 3, 3. And etc. So now we are going to draw the graph of this function. So let this as x-axis and this as y-axis. This is the image axis, y. So first of all, let x equal to -3. So this is the value of x. So x equal to -3. Now we will get the answer. -3 is equal to -3. So this is the f of -3. So this is the point intersecting these 2 points. So this is the point 3 comma x comma y, -3 comma -3. This is the point -3 comma -3, that is x comma y. Next, -2. This is the x value, -2. What is the y value? It's again minus 2 because this is identity function. So again minus 2. Sorry, there's a mistake. This is not minus 2, this is 3. Sorry, this is my mistake. Actually, this is not 3. This is minus 3. This is minus 3. It's my mistake. So this is the point, intersecting point, minus 3, comma, minus 3. And look at here. What's the image of minus 2? Is again minus 2. So this is the point minus 2, comma, minus 2. What about minus 1? Minus 1, image of minus 1, minus 1. So this is the intersecting point, minus 1. And 0, again 0. 1, image of 1 is again 1. So this is the point 1. This is the point 2. And this is the point 3. So actually, in between minus 3 and minus 2, we can find minus 2.5. And also in between 0 and 1, we can find 0.5. Here we can find 0.75, 0.25. There are so many numbers in between 0 and 1 because this is real number. So we will get every number in between these. So by drawing like this, we will get the correct graph of this given function. This is the graph of the given function, a straight line. A straight line. The arrow mark indicating this is not finite. This is continuously going. Okay. And look at the next example. Constant function. Constant function. F from R to R by f of x equal to c. C is any constant. C is any constant. Then we will get image of minus 3. F of x equal to c. Then f of minus 3 is c. F of minus 2, c. F of minus 1, c. Image of 0, c. Image of 1, c. Image of 2, c. Image of 3, c. So for every real number, the image of that real number should be c. That is called constant function. So here I am letting this c is equal to 2. If I am letting c equal to 2, then we will get the graph like this. The image of 3 is 2. This is the line 2. Image of 3, 2. Image of minus 2 is again 2. Image of minus 1 is again 2. Image of 0 is 2. Image of 1 is 2. Image of 2 is again 2. Image of 3, 2. Image of 4, 2. So every number, the image is constant. So we'll get the graph like this. This is not finite. So this is the graph of a constant function. Actually, this is a straight line. You just write with a scale without any float. Okay, just write with a scale. Then you will get a correct straight line. This is a graph of a constant function. Actually, look at here. Here, f of x equal to c. So in every number we will get, look at here, if I am writing like this, if I am writing like this, here we have minus 2, minus 1, minus 2, 0, 1, 2, 3. And what is the range? Here we have only the image c. So the range is c itself. So we can say that the range of this function is equal to set to c. Because every element has the image c. So we can say that range of this function is c. What's the domain? Domain, set of all first numbers. Actually, what is first element? It is not minus 3. So first element is starting from real numbers. So the domain of this function is set of all real numbers. What is codomain? Codomain is the ending function. It's also real numbers. Okay.